Hello everyone. Hope all of you are doing well. Let's begin with our topic, the how to crack the gate civil engineering with just 10 hours of study. So today we are discussing about our first hour course out of our 10 hour. This will be the one of the most important topic because we are studying today the regarding the gate civil engineering geotechnical part. From as I discussed earlier, from geotechnical there will be two lecture. Today we will discuss about the lecture one. This is going to be most interesting and most important for upcoming gate examination, and I will share all the trick how to remember the equation, and what are the minimum thing you have to remember, and how to bring all the information based on this minimum information. So I hope this trick will be very helpful, and it will be really helpful during the exam hour also, because at the exam hall you will be in the most tension zone, you will have most peer pressure, so you may have commit some kind of mistake. So avoiding some mistake, I will give you a simple trick how to remember what are the mistake you generally committed during the examination, so it will be helpful for you. Okay, let's begin our geotechnical part 1 lecture. This is the lecture 1. Okay, let's go to my okay. So geotechnical part 1, as I already discussed, this is a total 10 number of lecture are there. Out of this 10 lecture, we are just commencing the lecture 1. This is geotechnical part 1. In case geotechnical part 1, let us begin with properties of soil. The most important, okay, in case of properties of soil, as we all know, this is solid, and this is your water, this is your air. Okay, just consider this is the volume, of okay, this is your volume of solid, volume of water, volume of solid. This part is volume of solid, this part is volume of water, volume of air. Similarly, if we denote volume in this side, volume of air, volume of water, volume of solid, and these to consider one together, volume of void. This is weight of the solid, weight of the water, weight of air. Okay, uh, for the sake of simplicity, you just remember that's remember in this way. Okay, this is solid, this is water, and this is we all know this G is specific gravity. In case of G rho W, water means rho W, air is void. Okay, this is the area. For that point of view, just quickly we recap everything. Volume of void by volume of solid is equal to void ratio, and porosity is equal to volume of void by total volume. And most important, what to remember in this equation, in this area, that for the easier calculation, if you consider that volume of void is equal to E and volume of solid is equal to 1. Okay, just remember that part, only this part you have to remember, only this area, only this part. If you remember, everything will be completed, this entire chapter is completed. Okay, then void ratio, volume of void by volume of solid, and porosity of volume of void by total volume. That's it, anything else? Now we are for density. Okay, bulk density is equal to, bulk density will be what we know, that density equal to density is equal to mass by volume. Then bulk density is equal to mass means what? Mass of solid plus mass of water divided by total volume. Then what will be total volume? Void, consider 1, solid 1, the E and 1 plus E. Then for mass of solid, what? G into rho W plus G to plus G into rho W plus what? Rho W water. In case of there must be some water, na? So water for which area will water occupy? The voids means E will be occupied with water. Then in front of UE the quantity of S means saturation, degree of saturation means what? Volume of water divided by volume of void. So S is also required. E means void ratio. How means the total void is there quantity wise. S is the quantity. Okay, so E and S, just place E and S so that into gamma means it will become what? The E, the total volume of that, total weight of the water. I hope it's clear. This is your density. That's it. Okay, if it is dry soil, then S equal to 0, then rho become rho D, then it's become 0, G rho gamma by 1 plus E. Completed another equation. If it is saturated, there must be some E S. Okay, if it is fully saturated, then S equal to 1, then rho saturated is equal to what? G rho W plus E by 1 plus E. What we can write? G plus E rho W by 1 plus E is completed. You rho saturated, dry density, everything we will. What about that? Then rho submerged, rho saturated minus rho saturated minus rho W is submerged. Anything, everything. I hope everything will be clear. So what we have to remember, this area we have to remember. For water part we use rho W, for GW is the specific gravity. One additional important equation is S equal to GW. This entire chapter is completed. Now let's draw a graph. Okay, in that graph we will place we will place more things there in this way. Okay, let us, this is regarding our quantity of water. Let place volume, and in this direction let place water, means water content. Water content in W. The volume will be maximum according to the volume in the place of graph volume with respect to the water content. In that zone it will become up this way, and it will make the, this is the volume of liquid water. This is your liquid limit, this will be your plastic limit, this will be your shrinkage limit. Okay, wait, let me explain in a very simple way. Just consider volume versus water content. Now it is in the solid state, having some shear strength. We are sorry, it will be in the shrinkage limit, means the if water is further we reduce, okay, so it will no more shrink, it's a shrinkage limit. Now what we the water content at shrinkage. Now what we or solid as you wish. Now we just increase the volume of water, then this in this zone it may be, in that it will be lose some of the shear strength, and what we denote it is a plastic, okay, then P. In that case this becomes semi-solid, okay, and that semi-solid, it becomes semi-solid. I hope it is clear. There will be plastic water content, okay, WP. And the similarly further if we increase the volume of water, it will be liquid limit. After that the soil will flow like water, means shear strength is equal to 0. That's it. Up to this much we have to remember. Just complete it. That's it. Up to this area we have to remember. So plasticity index IP is equal to liquid limit minus plastic limit. Now listen very carefully. If WP is more than WL, WP is more than WL, in that case the IP will become negative. In that case also we will consider it as a 0. Okay, this is an important concept, okay, most important. So if IP becomes 0, it indicates what? It indicates a sand is, okay. Now if we mix sand with clay, sand means what? Non-plastic, because IP is become 0, because IP becomes 0. If IP becomes 0, this means it's non-plastic. If the soil is non-plastic, means sand. Now if I mix sand with clay, what it indicate? It will reduce. Sand is what? Sand is non-plastic. I hope it's clear. And clay is plastic because it has IP. IP means, let me show once again. IP means liquid limit minus plastic limit. Liquid limit minus plastic limit. For the case of uh, clay and mixing of sand, in that case the clay liquid limit and plastic limit will be reduced. So it is possible to change or reduce the plasticity or liquid index of a soil is possible. That's important concept. It will generally ask in a different terminology or different statement wise, master statement. This kind of question is generally asked. Okay, let's go to the note again. Now for liquid limit, and plastic in both the case, we conduct the Casagrande apparatus test. In case of Casagrande apparatus test, 425 micron ISC we generally use. This is important one. In the upcoming exam, GATE exam, it will most probably appear this question. 425 micron ISC we generally use in Casagrande apparatus to seed the soil sample. Okay. In liquid limit, if we draw a curve between water content and number of flow in log scale, okay, number of flow in log scale, then when it come to 25 number of flow corresponding to test, we consider it as a liquid limit. Clear? This chart is also known as flow chart. Flow chart, and accordingly flow index is appear. Then flow index is equal to your means change in water content divided by change in number of flow. Clear? Consider this way, okay, and this way. Number of, consider the changes between n1 to n2, okay, n1 by n2. That's it. This is known as flow chart, and this is known as flow index. That's it. Okay. Then activity. IP divided by percentage of clay finer than 2 micron. Okay, this is one of the most important question. This is also important, and the additional term is there. This is called relative density, also known as density index. This is nothing but the E max minus E at site divided by E max minus E minimum. As we discussed earlier, I hope you remember that rho D is equal to G rho W by 1 plus E. Okay, so what we have observed that we can write that E equal to G rho W by rho D minus 1, means E is inversely proportional to the dry density. Then we can write in the same way, E max means 1 by D rho D minimum minus 1 by rho D at site divided by 1 by maximum 1 by rho D minimum minus 1 by rho d maximum. That's it. This is your relative density. Okay, let's move to the next topic. Then uniformity coefficient equal to d60 by d10. d60 means what? d60 means percentage of particles. d60 means percentage of particle finer than the given size. d60 60%. d10 particular, the size of the particle is finer than the given size. This is called d10, and d10 is also known as what? It is also known as effective size. Okay, then uniformity coefficient, then coefficient of curvature, cc. This is cu. cc is d60 d30 by d30 square by d60 d10. That's it. Now Indian standard classification system. Okay, IP means plasticity index and the liquid limit. Okay, 10, 20, 30, 40, 50, 60, 70. Okay, one is 35. Okay, just remember that one. It's 35. Okay, okay. Now draw another line from 20. Anything above the 20 line is known as, it will be clay. Anything below that line will be silt. Silt be represented by M, clay represented by C. Clear? Any doubt? I hope there is no doubt. Now anything which is in between 0 to 35 is low no compressibility, and this intermediate compressibility, this high compressibility. Clear? Low, intermediate, high. Below 20, this line is also known as A line. There is an equation for A line. IP is equal to 0.73 WL minus 20. Okay, and this chart is known as plasticity chart. This chart is known as plasticity chart. IP is equal to 0.73 liquid limit minus WN minus 20. Okay, this is known as A line. Above the A line is clay, below A line is silt. Okay, and three categories are there: low compressibility, intermediate, and high. Three type of. Okay, clear? Okay, next. Now let us discuss about the permeability. In case of permeability means the property of soil allowing soil sample to pass the water through it. It is called permeability of soil. In case of permeability, the additional important term is gradient. Means hydraulic gradient. Hydraulic gradient means what? Hydraulic gradient means the difference between the head pressure and the length, due to which head pressure a soil sample, this is considered, this is a soil sample, the this is your head difference, okay, and the length, how many, due to this, let me show you in the diagram. Okay, let us consider that this is a soil sample. Okay, this is your soil sample and this is connected with a vent pipe. Okay, similar this way, and this is the length of your soil sample. And if it is length of a soil sample, then initially the head is this up to this level, so we consider it as H1, and finally it becomes this area, then it considered as H2. This is your head reference. Then your hydraulic gradient I is equal to this head difference H2 minus H1, hydraulic head difference H1 minus H2 divided by your length. That's it. Now according to Darcy's law, for laminar flow in homogeneous soil, velocity of flow is equal to Ki. Okay, K is coefficient of permeability, I is hydraulic gradient. Okay, there are two type of tests we generally conducted to determine the permeability of soil. One, constant head permeability test. On this test, if you consider the similar soil sample, we know discharge of water Q equal to A into V, and velocity, we from the Darcy's law we know velocity V equal to Ki, A V equal to Ki, and then A Ki means what? H divided by L, we already know H divided by L. Then find out the value of K. K is equal to what? Q into L by H is your value of coefficient of permeability. This is your constant head permeability test. Another one is variable head permeability test. Okay, on that case the value of K is equal to AL. This is your keep what STA and distant pipe. This is the area of this pipe is AL divided by AT log H1 by H2. How to remember that thing? In that occasion, the capital A on the bottom of the equation, similar the capital A on the bottom of the equation, and the capital L in the top of the equation. This is in the same way, capital L in the top of the equation. The same way, just similar thing. Okay. Variable head permeability test is most suitable for very fine and silt. Suitable for sand and silt. Okay, now next. Now factor affecting permeability of soil K is equal to C W by mu into E cube by 1 plus E d square, where K is coefficient of permeability, C is structure of the soil, and common unit weight of water. U is equal to viscosity, void ratio, D is equal to particle size. If it is coarse grain, then it's higher, than fine grain is lower particle size. Okay, so only remember this equation. This equation is really helpful to solve various MCQs or various questions in the GATE examination. In the recent past, they have asked many questions. For example, they have asked a question where temperature variation with the variation of the permeability. In the same equation, if you know that simple equation, everything will be constant. Only because of temperature, viscosity will be changed. Then you may consider that V into nu equal to C into rho W A cube by 1 plus A t square. Then this part will be constant. It will be this way. Okay, in that question they have given that if the coefficient of permeability K in 30 degrees centigrade is X, then for 20 degrees centigrade K 20 is equal to what? This question is asked. You just simple, now you know that K into mu is equal to constant. You just remember this equation. This equation gave you the every type of solution. Okay, just remember that thing. Now Laplace equation for two-dimensional flow, Kx d2h dx2 plus Ky d2h dx2 equal to 0 for anisotropic soil. Okay, and for isotropic soil, d2h dx2 plus d2h dy2 equal to 0, because for isotropic soil kx equal to ky. Clear? Now let us draw a flow net. Before drawing flow net, let's draw a flow curve. Means if we construct a dam, let us construct a gravity dam. Okay, this is your water level in this zone. This is your H1. Okay, this is upstream and this is your downstream. This is H2. There may be a tendency to flow the water. Okay, na? Let's consider this is your datum. Okay, so there will be a tendency to flow the water. Maybe this way. Okay, to identify, to easily understanding this, let's draw a flow curve first. That this way maybe their water is flowing. Okay, this is your steam line. Okay, the way it is flowing, let's consider this a psi, and this one will be psi plus delta psi. Okay, and there will be, for that point of view, there will be equipotential drop, because the pressure difference, this is your stream flow line. Okay, This is the equipotential line. Equipotential line. Potential line is constant. This is phi. Okay. This is your phi plus delta phi. That's it. This, so let us say elementally it is a B, and the entire thing flow curve. This is known as flow curve. Okay, this is known as flow. This is known as flow curve. That's it. Then flow line and equipotential line. This is your flow line. This line is a flow line, and this is your equipotential line. This one, if I withdraw this way, this is your equipotential line. Flow line and equipotential line orthogonal to each other. Okay. Then the area bounded between two flow line is called flow channel. Flow line, this line and this line, known as area between these two lines is known as flow channel. Okay. So if the number of flow line we know, then we easily find out the number of flow channel. Number of flow channel equal to number flow line minus 1. Similarly, number of equipotential drop is equal to equipotential line minus 1. Okay, equipotential minus 1. Then everything we know now. In case of it is isotropic, as we know now, this is isotropic. In case of it isotropic, this flow curve, this flow field, flow curve or flow field, this zone is known as flow field. This flow field is square for isotropic. For anisotropic, it will be rectangular. For isotropic, it will be square. For anisotropic, it will be rectangular. That's it. Why it is rectangular? Because this is vary, this ky, k2, there is something that is influencing. That's why it is vary. That's why. Okay. I hope you will be easily remembering everything. This is your flow line. This is your flow line. This is your equipotential line. Okay. Flow line minus 1 is equal to flow channel, and equipotential line minus 1 is equal to equipotential drop. Clear? Now you have to just remember that discharge Q equal to K H into NF by ND. This is the only thing you have to remember, and nothing else you have to remember. You have all the thing I already discussed to give you the understanding, but you only remember this equation: Q equal to KH into NF by ND. NF by ND. Okay. This NF by ND is also known as shape factor. NF by ND is also known as shape factor. Okay. Let's go to the next topic. This is stability of slope. Okay. On that, the entire stability of slope is based on their factor of safety. This term is most important. The factor of safety in case of stability of soil, the shear strength of soil divided by shear stress of soil. The only important equation, or the only important equation you have to remember, that is factor of safety is equal to C plus gamma is C cos square beta tan phi divided by gamma is C cos beta sin beta, where beta is equal to slope angle or inclination angle. Okay, if it is a slope, okay, this is a slope, then this is where beta, and phi or theta is equal to, and phi is equal to your frictional angle. Okay, this is the most important, and this is the only important equation. You have to just remember that equation. Okay, for cohesionless soil, C becomes 0. Same equation, you just remove C, then what happen is this will be cancel out, this will be cancel out, only there will be tan phi by tan beta. That's it. For C phi soil, in case of critical section, means the when factor of safety will become 1, the soil is about to fail. This is a factor of safety become 1. In that case, a factor of safety is equal to 1. Put the same equation, C plus gamma is C cos square beta, then tan phi divided by gamma is C cos beta sin beta. Then as it is 1, then find out the value of C. C will be what? C will become gamma is C cos beta sin beta minus gamma is C cos square beta tan phi. Now take gamma is C common, then what we will get? Cos beta sin beta minus cos square beta tan phi. Okay, this term is known as Sn, means stability number. Okay, Sn means stability number, means what we get? C is equal to gamma is C Sn. Okay, gamma is C Sn, then Sn equal to C by gamma is C. That's it. The only one equation, if you remember, the entire topic will be on your hand. Now move to the next topic, that is our vertical stress due to the concentrated load. There is a most important equation from which is given by the Bosniaski based on some assumption. Bosniaski equation assumptions. Okay, Bosniaski. The assumptions are that an elastic, okay, homogeneous elastic homogeneous, then elastic homogeneous isotropic, most important. Okay, then semi-infinite, and the soil is wetless. These terms are most important because this assumption generally acts in a different way. Okay, isotropic, homogeneous. Okay, so for isotropic, Bosinian equation are mostly for isotropic. Okay, the equation of Bosinian, the vertical stress sigma z is equal to, this is one of the most important equation. Okay, 3q by 2 pi z square. Okay, let me write it down first, then after I will explain, because this is one of the most important question. 1 by 1 plus r by z square all to the power 5 by 2. Let's consider a plane. Stress is, we have to find out the stress in this point, or we have to find a stress in this point. Then this is the vertical depth is z far up in a distance of r. Okay, now it's clear what is z, what is r, and this is your q, z, r, everything is given. The Bosinian equations look like similar. Okay, now, and this is relevant for the isotropic. If it is anisotropic, in that occasion, anisotropic, in that occasion, the equation become sigma z q, just this term we will shift, q by pi z square 1 divided by 1 plus 2 into r y z square all to the power, we will 3 by 2 this 3 by 2 we will put as a power, then 3 by 2, just put it 2 extra here, that's it. In case of anisotropic, this is for anisotropic, this is for isotropic. Okay, and for circular section, for example, if there is a load imposed in this way on a vertical, on a ground, the load is imposed in this way. On that scenario, the stress become sigma z become q by pi z square, similar to this one, similar to this phenomena, we will use q by pi z square, or you can simply write in different way. Let me give you the example. Q into 1 minus 1 by 1 plus r by z square to the power 3 by 2. Similar to the previous equation, just put a one extra 1 minus, that's it. I hope this is really help you, because I give you the most important area where you have to be focused, and based, if you keep the importance which I highlighted very categorically, that you just go through this equation, this diagram, this will really helpful for you, because at the end of the day you have to remember the equation and you have to implement the equation. During the examination you don't have that much of time, because your aptitude will take time, in mathematics this portion will definitely take time, some valuable time from you. So try to collect, I not more than 10 equation or 10 I give it to you for today's session. So you just go through these important equations and try to practice PYQ. If you have any query or any doubt, you just pin me or you give me, DM me, anything you can do, or give a comment, you will easily solve, because I give you the insight of how to remember the equation. You don't need to go through the entire syllabus or entire textbooks every time. Just go through the video, you will find the important equation. Based on the equation you just implement. that today's session I give you the around 10 equations and probably three diagram I give you. So this 3 diagram and 10 equation is more than sufficient for what I give you today. In the next session I will come up with some the geotechnical part 2, and that paper and that lecture I will complete the entire geotechnical, and after that you will solve even though your foundation engineering also. So I hope this video will give you all the clarity. This 10 equation is most important, 3 diagram are most important. Every year there is some question from that uh, area which I highlighted and discussed with you. In case of permeability chapter, I give you equation. This is also important. So try to uh, have an overview from the beginning, so that it will be helpful for you. That this is our initial three-phase diagram. We just highlighted that this only this portion you have to remember. Based on that you will write the all equation, and this equation if you go, then after each and every equation you can easily write. Okay, this is first. This is a simple diagram that your plasticity index important equation. If it is 0, what it will happen, then what is activity, then rodent. Okay, then your coefficient of curvature, then your liquid plasticity chart. Okay, constant head parameter test. This equation is once again, this is one of the most important equation. So NF by ND, yes, this was NF by ND, KH equal to Q equal to KH NF by ND. This flow curve. This is for isotope it is square, for anisotope is rectangular. So, and this is the one of the by remembering this equation only, the entire stability of soap chapter is completed, because whenever there is a critical condition this become 1, and you will find the SN value. This is important question, and the most important in every alternative year in the GATE examination. This question is appear, and the Bosinius equation assumptions are important as I highlighted. And if you need the any notes or the summarized note or the note which I have prepared from, anything you need, you just give me knock me, or you give me your comments. I will assist you. Okay, thank you. We will once again meet for the upcoming session for our geotechnical lecture 2. Okay, thank you.